each and everyone. The concept of this video is to understand and explore what is the purpose of science, matter, energy, and system in our environment. Knowing these fundamentals are crucial part for us humans. Why? The fact that these fundamentals are one of the most concepts that we need to be aware of. It helps us know the reality, not just that, but also we are able to aware what will happen if our environment could not sustain anymore. Further for that, we will explore the science, the matter, the energy and system. So take a look and listen and learn.
Science is a systematic approach to understanding the natural world, encompassing the study of various phenomena, processes, and phenomena through observation, experimentation, and rigorous analysis. It seeks to uncover the underlying principles that govern the universe, offering us insights into the workings of the cosmos and enabling us to make informed predictions and advancements in various fields of knowledge. Through its methodical inquiry, science strives to expand your knowledge, challenge existing theories, and provide a reliable foundation upon which we can build our understanding of the world around us. The scientific method plays a vital role in conducting experiments and making observations by providing a structured and systematic approach. It helps ensure that research is conducted in a logical and rigorous manner, allowing for reliable and valid scientific knowledge to be generated. We could also include observation. The scientific method begins with making observations about a particular phenomenon or problem. Observations can be made through direct sensory perception or by using instruments and tools to gather the data. Next key is formulating a question. Based on the initial observations, scientists formulate a clear and specific questions or problems to be investigated. This question guides the research and experimentation process. Another key is the hypothesis. A hypothesis is a proposed explanation or educated guess that attempts to answer the question or solve the problem. It is formulated based on existing knowledge, previous observations, and logical reasoning. We could also include experimentation. Experimentation, scientists design and conduct experiments to test their hypothesis. This involves manipulating variables, controlling conditions, and gathering data. The experiment should be carefully designed to ensure reliable and valid results. Another key is data collection and analysis. During the experiment, scientists collect data by making further observations or measurements. The data is then organized, analyzed, and interpreted to determine if it supports or refutes the hypothesis. The last key is the conclusion. Based on the analysis of the data, scientists draw conclusions about the hypothesis. If the data supports the hypothesis, it may be considered as a valid explanation for the observed phenomenon. If the data contradicts the hypothesis, further investigation or modification of the hypothesis may be required.
Segment number 2. Matters and its properties. 1. Explore the concept of the matters as anything that has mass and occupies space. The concept of matter is fundamental to our understanding of the physical world. Matter refers to anything that has mass and occupies space. It is the substance that make up all objects and substances in the universe. Matter can exist in various forms such as solid, liquid, and gases. Solid are characterized by definite shape and volume. The particles in solid closely packed and has strong attractive forces between them. Example of solids include rocks, woods, and metals. Liquids, on the other hand, have definite volume but change shape to fit their container. The particles in the liquid are less closely packed in the solid, allowing them to move and flow more freely. Example of liquids includes water, oil, and milk. Gases have neither a definite shape nor a definite volume. The particles in a gas are widely spaced and move freely, filling the entire space available to them. Example of gases includes air, oxygen, and carbon dioxide. It is important to note the matter can also undergo changes in state, such as melting, freezing, evaporations, and condensations, depending on the changes in the temperature and pressure.
Hi, I'm Rachel and Palomera, and I'm going to discuss the states of matter, the solid, liquid, and gas, and also the properties of matter, mass, volume, and density, and lastly, the changes of matter, which is the physical and chemical. So, let's delve into the states of matter, properties of matter, and changes in matter. States of matter. As mentioned before, matter can exist in three primary states, the solid, liquid, and gas. So the first one is solids. Solids have a definite shape and volume. The particles in a solid are closely packed and have a strong intermolecular forces that hold them in place. This results in a rigid structure. Examples, this includes the ice, wood, and iron. So the second one is liquids. Liquids have a definite volume but take the shape of their container. The particles in a liquid are closely packed but have more freedom to move and slide past each other. Liquids have a weaker intermolecular forces compared to solids. So the example of liquids, this includes the water, oil, and milk. And so the last one of the states of the matter is the gases. Gases have neither definite shape nor a definite volume. The particles in a gas are widely spread and move freely, colliding with each other and the container walls. Gases have weak intermolecular forces, so the examples of the gases are, this includes the air, the oxygen, and carbon dioxide. So now, let's proceed to the properties of matter. Matter has several properties that help describe and differentiate substances. So the first one is mass. Mass. This refers to the amount of matter in an object. It is a measure of the inertia or resistance to change in motion. Mass is typically measured in grams or kilograms. The second one is the volume. Volume is the amount of space occupied by an object or substance. It can be measured in a cubic unit such as liters or cubic meters. And the last one of properties of matter is the density. Density, this is the mass per unit volume of a substance. It is calculated by dividing the mass of an object by its volume. So density determines whether an object floats or sinks in a particular medium. And so the last one is the changes in matter, which is the physical and chemical. So physical changes do not alter the chemical composition of a substance. Examples, this includes the changes in states such as melting, freezing, vaporization, and condensation. So the changes in shape or size like cutting, crushing, and bending. And also the changes in appearance, the dissolving and mixing. So the last one is chemical change. So chemical change involves a transformation of a substance, resulting in the formation of new substances with different chemical properties. Examples, these include the burning, rusting, digestion, and fermentation.
Good day, my name is Mary Kumbang, and I will discuss the energy and its forms and introduce energy as the ability to do work or cause change. Absolutely, energy is a fundamental concept in science and plays a crucial role in our everyday lives. It can be defined as the ability to do work or cause change. Energy exists in various forms and can be converted from one form to another. Here are a few key points about energy. The forms of energy. Energy can exist in different forms, including mechanical energy, thermal energy, chemical energy, electrical energy, light energy, sound energy, and nuclear energy. In mechanical energy, the energy possessed by an object due to its motion or position. It can be divided into kinetic energy and potential energy. Kinetic energy, it is energy of motion, while potential energy is the energy stored in an object or position or shape. Thermal energy, the energy associated with the temperature of an object. It is related to the random motion of particles with a substance. Chemical energy, the energy stored in the bonds between atoms and molecules. It is released or absorbed during chemical reactions. Electrical energy, the energy associated with the flow of electric charges. It powers electrical devices and systems. Light energy, the energy carried by electromagnetic waves, including visible light. It enables us to see and provides energy for photosynthesis. Sound energy, the energy produced by a vibration that travels through a medium such as air or water. It allows us to hear sounds. Nuclear energy, the energy released during nuclear reactions, such as those that occur in the sun or nuclear power plants.
I will discuss the various forms of energy, which are the kinetic, potential, thermal, and chemical energy. First, the kinetic energy. Kinetic energy is the energy of an object due to its motion. The amount of kinetic energy depends on the mass and velocity of the object. For example, a moving car, a spinning top, or a person running all possess kinetic energy. Number 2, potential energy. Potential energy is the energy that an object possesses due to its position or state. There are different types of potential energy. First, the gravitational potential energy. This type of potential energy is associated with an object's height above the ground. The higher the object is lifted, the greater its gravitational potential energy. For example, a ball held at the top of a hill or a stretched elastic band both have gravitational potential energy. Second, elastic potential energy is stored in objects that can be stretched or compressed. When these objects return to their original shape, they release this stored energy. A stretched rubber band or a compressed spring are examples of objects with elastic potential energy. Third, the thermal energy. Thermal energy is the energy associated with the temperature of an object or a substance. It is related to the random motion of particles within the object. The higher the temperature, the greater the thermal energy. For example, a cup of hot coffee has more thermal energy than a cup of cold water. Fourth, the chemical energy is the energy stored in the bonds between atoms and molecules within a substance. It is released or absorbed during chemical reactions. When bonds are broken, energy is released, and when new bonds are formed, energy is absorbed. Examples of chemical energy include the energy stored in food, fuel, and batteries. These are just a few examples of the many forms of energy that exist in our world. Energy can be converted from one form to another, allowing it to be utilized for various purposes.
Good afternoon, I'm Nenloy Malenya and I'm assigned for segment 4, Systems and Interactions. Define a system as a collection of components that work together to achieve a specific goal. A system can be defined as a collection of components that work together to achieve a specific goal or purpose. These components can be physical elements such as machines or tools, or they can be abstract such as processes or information flows. The components within a system are interconnected and interdependent, meaning that they rely on each other to function effectively and achieve the desired outcome. For example, a computer system consists of hardware components such as the central processing unit, memory, and storage devices, and software components such as the operating system and applications. These components work together to perform tasks and provide functionality to the user. Discuss the concept of interactions within systems and how feedback loops can affect the behavior of a system. Interactions within systems refer to the ways in which the components of a system communicate and collaborate with each other. Interactions can be both direct, where components directly exchange information or resources, or indirect, which components influence each other's behavior through feedback loops. Feedback loops are an essential concept in understanding how interactions affect the behavior of a system. A feedback loop occurs when the output or result of a system's behavior is feedback into the system as input, influencing its subsequent actions. Feedback loops can be positive or negative. Positive feedback loops amplify or reinforce the behavior of a system. For example, in a heating system, if the temperature rises above a certain threshold, the system may activate a feedback loop that increases the heating, which further raises that temperature. While negative feedback loops, on the other hand, work to stabilize or regulate the behavior of a system. For instance, if the temperature exceeds a set limit, the system activates a feedback loop that turns off the heating, leading to a decrease in temperature and restoring balance.
Hi, I'm Shermay S. Mulatan, and I will be discussing the 3 examples of real-world applications that illustrate the interplay between science, matter, energy, and systems. Examples could be ecosystem, human body, and environmental issues. Here are some real-world examples that illustrate the interplay between science, matter, energy, and systems. First is ecosystem. The relationship between plants, animals, and their environment in an ecosystem demonstrates this interplay. For example, in a forest ecosystem, plants convert signs through photosynthesis into food and oxygen. Animals consume these plants for energy and release carbon dioxide. Decomposers break down dead matter, returning nutrients to the soil, which supports the growth of more plants. This interconnected web of matter, energy, and systems sustains the balance and functioning of the ecosystem. The second is human body. The human body is a complex system where matter, energy, and science interact. For instance, the digestive system processes matter into nutrients that can be absorbed and used for energy. The cardiovascular system transports oxygen and nutrients throughout the body, ensuring proper functioning of cells and organs. The nervous system controls and coordinates bodily functions, utilizing electrical signals to transmit information. This interconnectedness between matter, energy, and systems allows the human body to function properly. The last one is environmental issues. Environmental issues such as air pollution showcase the interplay between science, matter, energy, and systems. When fossil fuels are burned, they release pollutants into the air that contribute to air pollution. Understanding the science behind these pollutants and their impact on the environment is important in developing strategies to reduce emissions. Renewable energy sources like solar or wind power offer alternative forms of energy that have fewer negative impacts on the environment. By studying the interplay between matter, energy, and systems, scientists can work towards finding sustainable solutions.
I am Bernadette Espaios. Number 2. Highlight the practical application of this concept in solving everyday problems. The interplay between science, matter, energy, and system has practical applications in solving everyday problems. Here are a few examples. 1. Energy efficiency. Understanding the concept of energy and system can help address the everyday problem of high energy consumption. By analyzing how energy flows through systems like buildings, appliances, and transportation, scientists and engineers can develop energy efficient solutions. These include technologies like energy efficient light bulbs, smart thermostats, and hybrid vehicles, which optimize energy use and reduce environmental impact. Number 2. Waste management. The interplay between matter, systems, and environmental issues is crucial in solving waste management problems. Scientists should study the life cycle of materials and develop systems for recycling and waste reduction. By understanding the properties of the different materials, such as plastics, metals, and papers, they can devise efficient recycling processes. This effort helps minimize waste generation and promote a more sustainable approach to resource usage. 3. Environmental conservation. The interplay between science, ecosystems, and environmental issues is vital in solving everyday problems related to environmental conservation. By studying ecosystems and the impact of human activities, scientists can develop strategies to protect biodiversity, restore habitats, and mitigate pollution. Conservation efforts such as reforestation project or the creation of protected areas rely on a deep understanding of the interconnections between matter, energy, and system in natural world. These are just a few examples of how the interplay between science, matter, energy, and system can have practical application in solving everyday problems.
Conclusions. Key takeaways. Science, matter, energy, and system, these fundamentals are very important to us humans. As science means everything, while energy helps us to move or to make actions, while learning matter provide us ideas and knowledges. And when we say system, it is the processes. For example, how can plants grow if there is no sun? Sun is our foundation of all, and also we keep in our mind that everything is connected to everything else. All bad actions we made to our environment, it will come back to us.